with our Juniper GRE. First, let me look at Juniper official GRE. Juniper GRE. See here. So we are going to discuss about Juniper routing essentials. This is a one-day classroom training which will provide students about routing knowledge and configuration examples, including routing policies and firewall filter. Okay. Official, they are delivering still 12.1x, but we are working on updated 15.1x. Official training will be on 12.1x only. Okay. But we are going to do on 15.1x, which is updated. So if we come down and see this, what are the concepts? Routing concepts, overview of routing. What is routing? How routing works and all the stuff. Then routing table, how routing table will be. And how to maintain multiple routing instances. Okay, how to maintain multiple routing instances. Then configuring static routing as well as dynamic routing. Okay, this is our first chapter. Actually, course introduction is nothing but GRE, what is GRE, what is all the stuff, waste of this basic. Then routing policy. Routing policy will discuss about how to configure policy based routes, how routing table will be identified if policy based routes are there, how precedence will be taken by your routing entries, and all the stuff we are going to create routing policies and we are going to see. Chapter 4, firewall filters. We are going to write ACLs and we are going to write take some scenario and we'll be doing a case study of ACLs. Then unicast reverse path forwarding, RPF, which we say in our other firewalls. In checkpoint we'll say anti-spoofing. Okay, in Fortinet we say RPF, Cisco we say RPF. Here we'll call it as URPF, unicast reverse path forwarding. Okay, firewall filters lab we are going to do. This is an appendix chapter, okay, which is your QoS, how to give priority for your traffic. So let's go and do this Juniper routing fundamentals. Okay, Juniper routing basics. What is routing? Routing is nothing but transferring packet from one network to another network, between one L3 network, layer 3 network to another layer 3 network. That is called routing, right? The same topology on the client side of several L3 networks, all connected to a router. Although routers are the most common devices for performing this routing, note that many switches and even security devices also perform routing. See, nowadays each and every firewall also can act as a router. Even L3 switches also can act as a router. A router is required to perform routing. What is meant by routing? Transforming packet from one L3 network to another L3 network. One network to another network, that will be, that process is called routing. Okay. Internet is a network of networks, right? Internet is also a collection of many networks which are part of same. Now see here, the process of moving data between layer 3 networks is called routing. If you observe this diagram, this is internet. From here we have one server which is in different L3 network, and here at user is in another L3 network. This router which is sitting here will be translating packet from moving one packet from one network to another network. It might be intranet or it might be internet. Clear? Routing components. What are the components of routing? What are need to be there? Minimum components. Two different networks, one router, and end-to-end communication path, that is cabling. Logical communication means logically we will be assigning IP address, and you need to specify the path, that is route. If it is static. If it is dynamic, we will enable protocol. And what we are going to specify? All layer 3 devices participating in the communication path must have the necessary routing information. That's what your path you are going to configure. The devices within the user and data center networks must have the proper gateway configured. That gateway is nothing but your router or your firewall, which is acting as a router. The gateway device must determine the proper next hop based on the destination. For example, I have multiple routing entries. In my routing entry, I have specified if destination is 20.network, that has to be given to the next hop, so and so next hop. If my destination is 192.168.3.network, what is the proper next hop? Okay, based on the destination only, next hop will be decided by your router. Okay, that information will be found in a routing table. What are components of routing? What are components of routing? For a device to communicate with other device in a remote network, what are the requirements? End-to-end communication path, that is cabling and logical configuration, and routing information on participating devices. Okay. Now check out this. If user A needs to communicate with a device within the data center, user A is sitting in 10.1.1. network, data center is in 10.2.2. network. If user A need to communicate with a device within the data center, what routing information do the L3 devices within the communication path? L3 device is nothing but your router require. Now user, understand, now this user want to communicate this data center, what information this routing table, this router should have? What routing information it should have? Next hop IP, not gateway IP. Packet when hits to this interface, to which next hop it has to given? Next hop IP address, that is nothing but 10.2.2.1 IP address. What information this router should have? To which next hop? If user is 10.1.1.1, destination IP address is 10.2.2.2. What is my next hop? 10.2.2.1. Look at the diagram, it is clearly given. If you look at this, source is this network, destination is this network. In this routing table, what information need to be there? Because there is internet also connected. Okay, so I should have a next hop of this. That is 10.2.2.1. This next hop information I need to have. My L3 device need to have. Okay, then only this communication will success, or else this communication will fail. See here, for any device, the same. For any device to communicate with other device outside the network, either it is directly connected subnet or a properly configured gateway is required. In this scenario, what we have seen previous scenario, user must have gateway configured to router IP address, and my router should have next hop as the next hop connected IP address. Okay. Routing table. What is routing table? What is routing table? A routing table is a set of information which will be either you will be statically configured based on destination to which next hop it has to, or it will be learning routes by using routing protocols such as OSPF, RIP, BGP. Okay, selects an active route to each destination. Select active route based on each destination. Populates the forwarding table. Once the routing table is done, then it is going to create a forwarding table and give it to PFE, right? Route engine will generate a route table and it will generate a forwarding table and give it to PFE. By looking that forwarding table only, PFE will forward to which next hop this packet need to be destined to. Okay, is it clear? Okay, and main unicast routing tables are inet.0. Remember, this is interview question. What is name of routing table of IPv4 in Juniper? inet.0. If it is IPv6, inet 6.0. Two routing tables will be there. One is inet.0, one is inet 6.0. IPv4 routing table is inet.0. IPv6 routing table is inet 6.0. Routing information sources. Junos OS routing table consolidates prefixes from multiple routing information sources such as either directly connected or statically written routes or dynamic routes. From where routing information will come into routing table is either by using static route or directly connected or using dynamic routing protocols, routing information will be populated into a routing table, right? Active route selection. When a device is running Junos OS receives multiple routes for a given prefix, it selects a single route as active route. With additional configuration, Junos OS supports multiple as well as equal cost routes. What this says, for a single destination, you have multiple routes. Packet won't be sent through all the routes. Packet will select one active route. Okay? How it will select? In next slides we are going to see. In next slides we are going to see what are the different decisions based on AD values, based on less distance. There are different ways, but active route packet will be delivered only through one route. It will take only one route. It won't take multiple routes. Even though multiple routes are defined to the same destination, one active route will be automatically selected by your routing table to forward data using from one source to a destination, right? Means, for example, in previous example we have seen user is sitting in 10.1.1.0, data center is in 10.2.2.0. Assume like that you have 10 routes to reach same 10.2.2.0 in your routing table entries, but it will choose only one route. That particular route is called active route. The route which was chosen to forward traffic from one network to another network is called an active route. Okay. Then forwarding table. A router uses this active route for each destination prefix to populate the forwarding table. Forwarding table determines the outgoing interface and layer 2 rewrite information for each packet forwarded by a device running Junos OS. What is forwarding table? Once routing table is designed, forwarding table is nothing but after routing decision has taken for the first packet, it will look into routing table and routing decision has taken, this active route I have to forward. Then it will be populating a forwarding table. So henceforth, if same source is sending to the same destination, it won't look into routing table once again. It will look into forwarding table. Using forwarding table, packet will be forwarded to the next hub, right? Then multiple routing tables. Junos OS can run multiple routing tables at a time. By default, primary routing table is inet.0, inet 6.0 is next one, but we have multiple routing tables. You can see those routing tables. Even you can customize or you can create your own routing tables. These are the default routing tables present in your Junos. If you want to look IPv4 routes, that will be in inet.0. Multicast forwarding table, if you are having video conferencing devices, you configure multicast traffic. At the time you need to check with inet 1. Multicast BGP as well as RPF. Multicast BGP as well as RPF information you will get in inet.2. Only MPLS routes you want to see, that will be part of inet.3. And used for multicast source discovery protocol route entries, MSDP, that will be inet 4. inet 6 is nothing but IPv6 and MPLS.0. This holds only next hop information of MPLS, not entire routing entries. These are by default present. We won't use in day-by-day communication. We'll be using inet.0, inet 6.0. If MPLS MUX connections are there, at the time we'll be using MPLS.0. Okay, for example, lot of companies will be having MUX connections, MPLS directly connections, lease lines, directly dragged. So at the time what we'll use? We'll use this MUX connections. Now, in your Cisco will be having AD values, right? Based on less AD value, route will be selected. Here we'll call it as route preference. Here we'll call it as route preference. Here also, less value is more preferred. Less value is more preferred, but the routing values are different. Check out, if it is directly connected, routing value is 0. Static route is having routing value as 5. OSPF internal 10. RIP 100. OSPF external 150. BGP 170. Now assume like that. from 10.1.1. network to 10.2.2. network, you have a RIP configured, you have OSPF configured. Which one will take precedence? RIP will take or OSPF will take? Is it internal OSPF or external OSPF? If you see the diagram, is it internal OSPF or external OSPF? Internal OSPF, right? So which one is having less route preference value? OSPF. So OSPF will take precedence. Like that, your routing table will take active route, will select active route. Okay? This is clear default route preference. This table you have to remember because interview questions will come, even certification exam you will be getting these questions. Remember OSPF, RIP, BGP and ISIS. These are the 4 important questions you will get in interviews as well as exam certification questions. Okay? Routing preference can range from anywhere between 0 to 4 lakh change. You can give any preference. You can even customize, you can give preference. But lower preference will be preferred. Already we discussed. Always lower preference value will be preferred. Okay? If you want to see a single route, see here, this is the command to see a single route. Means I have run a command called show route to a particular destination exact. I am giving a command if my system want to reach to a destination. What is the exact route? What is the exact route for it? हाँ बताओ बोलो नहीं बोलो किसका ओके कौन है ये बंदा ओके क्या पैकेज में बैठा एक्सलेंट प्रोफाइल भेज दो मेरा ट्रेनिंग चल रहा मैं एक आधा घंटे के बाद लेता हूँ ठीक है कोई दिक्कत नहीं नो प्रॉब्लम ठीक है कोई दिक्कत नहीं ओके आई विल डू दैट ओके ठीक है okay perfect. So if you are looking for a destination, to reach that particular destination, exact means it will take /32. Okay, in our next slides we will see what is exact, what is more. We have multiple options. Exact means only to that particular IP address. If my user try to reach, what will be the next hop? If you look at this, it is statically connected. Okay, first it will reach to 10.1.1.2 via this interface. Then it is looking using OSPF. It is connected to, from this it is using OSPF to reach to this particular destination. Okay, so first it is connected to this using static. Then from here it is connecting by using this interface. It is connecting to this using OSPF. Okay, now understand, you can even modify the default preference value for most of routing information, but in real time it is not recommended to modify default routing value. For example, your default routing value of OSPF is different, is 10, you want to make it as 50. You can make it, but in real time not recommended, because some other guy will join in place of you, will get struck out. Because of that, organization's compliance never agree, but yes, you can modify the preference values also. Okay, so perfect. Now the exception is with the direct and local routes, which are always preferred regardless of the modified route preference value. Always when you modified route preference value only will be taken. Now see here. Now I want to check out if I want to reach to this particular network. Show route. It is going to show you using static. I can reach like this. This is also another way. This is also another way. This is also another way. Okay. Assume like that. All are static. Means 4 routes are there to reach same destination. All are static. Then what it has to do? What other devices will do? If route preference matches, means same ID value, then we will look into metric. Okay, isn't it? Same way here also we have different methods. See, or else there is a service called ECMP, equal cost multi-path forwarding. Data will be shared among all the existing routes. Data will be shared among all the 4 routes. Show route. First it will show static routes, then it will show dynamic routes. Now understand forwarding table. Forwarding table stores information for packet forwarding operation. Contents include destination prefix and the associated outgoing interface. When forwarding table will be generated? After route lookup happens, every time for the same destination, for the same source, from the same source, it should not look for routing table. At the time this forwarding table will be populated, and forwarding table contains what? Destination. To reach that destination, what is next hop? Okay, so that is next hop. This forwarding table will be maintained by which plane? Control plane or data plane? Forwarding plane, PFE, packet forwarding engine, which we discussed in our day 1. See here, determining the next hop. Device compares incoming packet against forwarding table entries to determine the appropriate next hop. If multiple matches exist, it uses the most specific entry to forward packet towards the destination. If no matching entry exists, it sends a destination unreachable notification back to the source device. If routing entry is not there, what happens? Destination not reachable. Okay. Now use the following forward table to determine the next hop for the interface for packets destined to 172.19.52.101. Okay. So you need to identify what is the next hop for this. What is the most specific next hop to reach to the particular the next hop interface for packets destined to this IP address. If my destination is 172.19.52.101, first look only that and look at this routing table and tell me which route will be preferred. Let you check out. You tell one route. What is destination? 172.19.52.101. Which is most specific in it? Which is more specific?
19.0.
So if you observe, just this also will work, but the problem is /16 means 19.1 dot, 19.2 dot, 19.3 dot, 19.4 dot, everything. Then this is more specific, right? This is more specific, isn't it? Because 172.19.52 dot all traffic, more specific, isn't it? That's why routing preference will be taken by GE 0/0/1. Is it clear? So what about next one? 172.19.52.21. 172.19.52.21. 19.52.21, which will be the preferred next hop? Look at clearly and tell us the answer. $16. So destination is 21. Is it part of 16/28? Check out here. How many hosts can be added in this? Only 4. You need to be good at subnetting and supernetting. This will be preferred because this range also allows 21. Okay? This range also allows 21. In your subnetting class, you will be learning this. Okay? What about 172.25.100.27? Which one will be taken precedence? This 100 dot network is nowhere mentioned, isn't it? 100 dot network is nowhere mentioned, so it will take default route. What is your default route? If these are specific routes, these are specific routes. When these are not the destination, so destination is not of 172.19 dot. So it will look into this. No, this didn't match. So it will look into default, destination default for any next hop is GE 0/0/0. So this packet will be sent through GE 0/0/0. Is it clear? For this you need to be good at subnetting. Overview of routing instances. What is routing instance? Routing instance is a collection of routing table along with routing protocols information. Why routing instance we'll call it as? For a single router, on a single router, you can maintain multiple routing instances. In other firewall languages, we'll call it as virtual routers. VR. Virtual router means a single device can maintain multiple virtual routing instances. Okay? For example, I have 5 interfaces. 2 interfaces I want to maintain different routing table. Another 2 interfaces I want to maintain different routing table. You can create multiple routing instances. Each routing instance is having a dedicated routing table. Each routing instance having a dedicated routing table. Assume like that for my device interface GE 0/0/3, I created one more routing instance. Any traffic which is passing through that particular interface, that won't look into your default routing table, that will look into the routing instance to which you have attached that interface. You can create multiple routing instances based on your requirement. So routing instance is a collection of routing tables with which interfaces are enabled in that particular table and routing protocol information. Okay? You can run multiple routing instances in your Juniper. And what is the advantage of running multiple routing instances? What is the advantage of, it will give flexibility for device to make packet transfer very fast. For example, just take this. This interface I have connected to one network. This interface I have connected to another network. Okay? So if I need to write hundreds of routes I need to write in my network because I have hundreds of branches to connect. So if I write routing table, 100 routing entries are there. Okay? If both I configured on same routing instance, this is connected to internet. All public routes I need to write in this. This is connected to intranet. In intranet also I have multiple networks. So both traffic need to go with all 100 routing policies. To avoid that, what I'll do, I'll make 2 routing instances. All internal routing information and routing stored in this routing table. All external routes which I am writing, that I'll create in another routing instance. I'll attach this interface to that particular routing instance. So when external traffic is verified, that will be verified only with external routes, which is a routing instance of external. Okay, when traffic is moved from one L3 network to another L3 network within the internal network, that I am attaching to another routing instance which will check only that. Instead of 100 policies to check both, I have created 50-50. So this interface will check only internal 50. This interface will check only external 50. Reducing load or not. Multiple routing instances will be giving flexibility for administrators to configure, which makes your load easier. You can configure multiple routing instances. Okay, so Junos OS logically group routing table, interface and routing protocol parameters to form an unique routing instance. The device logically keeps the routing information in one routing instance apart from the other routing instances. The use of routing instances introduce great flexibility because a single device can effectively imitate multiple devices. The master routing instance is the primary instance of all devices running in Junos OS, that is inet.0. This is your master routing instance. Any packet will look into this master routing instance only for the first time. Okay. After that only you are going to create multiple routing instances. Okay. Such as multiple routing tables with respective name. You can create any name for your new routing instances which you are creating. Okay. See here. This is your master routing instance. How to see? Show route instance will show your master routing instances as well as your other routing instances. See here. Primary RIB, Juniper private forwarding. This is one routing instances. Another routing instance is Juniper private 2 forwarding. Okay, master is there. Master is inet.0 if you observe. Master name you can't modify. Master is your inet.0, but you have created other two routing instances called Juniper private 2, Juniper private 1. Okay. How to create a routing instance? Go to edit routing instances and create your own routing instance. Create your own routing instance. And routing instances also you can create multiple routing instances called L2 VPN routing instance, L3 VPN routing instance, virtual router or VPLS or VRF. So what are those? See here, clearly telling forwarding routing instance used to implement filter based forwarding. Filter based forwarding for common access layer applications. You can use filter based forwarding called as FBF in real time. Filter based forwarding. Okay. And L2 VPN used for configuring L2 VPNs, layer 2 VPNs. Okay. And no forwarding is nothing but don't forward instance, look into default static routing entry. Default routing entry, that is nothing but inet.0. Okay. Then virtual router. Virtual router used for non-VPN related applications. You are creating a virtual routing instance. If you want to create a virtual routing instance, then we'll use instance name as virtual router, VR. Okay. VPLS is nothing but multiple point-to-point LANs. Between multiple point-to-point LANs, you want to implement a VPN. Multiple point-to-point LANs, assume like that I have 192.168.1 network in internal network, 192.168.2 network in internal. Both are internal, both are L2. Between these two, I want to build a VPN. Means any traffic which happens from 192.168.1 to 2 or 2 to 1, I want to implement a VPN. At that particular state, we'll be using VPLS. Okay. Then the last one is VRF. This is very beautiful instance, especially when you are using layer 3 VPNs. Our regular VPNs which we do, that is layer 3 VPNs, right? For that, we will be creating VRF. Okay, in IPsec VPN class, you are going to see how to build VRFs to configure multiple VPNs. See here, edit routing instance and give you instance name. You will be giving your instance name as some whatever name you want. And what type of instance it is? I am creating a virtual router. Assume like that, just understand this network is connected to 100 internal networks. I will write a routing instance of those 100 routing networks. I will add only this interface part of that particular routing instance. So any traffic which will move from this particular interface will look into that particular routing instance. As we discussed, in internal network I have, in internal, if you check just Wipro is having internal, they are having hundreds of networks. All networks should be intercommunicatable. This cable is connected to a switch. This cable is connected to a switch. All internal networks are in different VLANs, all are connected to each other. Okay? So at that time what I will do, I will create a routing instance of all those 100 networks. I will add only this interface to that particular routing instance. Only this interface. Okay? In external, in other branches of Wipro, I am having multiple networks. In other branches of Wipro, I am having multiple networks. This cable is connected to internet. Using internet only, other branches are connected. All routes related to that particular traffic, that particular networks, I will create one more routing instance and I will add this interface into that instance. Now a user who is sitting in internal network is trying to reach one more internal network, that will look into which routing instance? The internal connected routing instance, right? That is not having all 100 rules, that is having only 50 routes which are related to 50 internal networks. So it will look into the next hop and it will move. Then if the same user is trying to reach one more branch of your Wipro, then that will be forwarded through which routing instance? Through WAN interface, right? My next interface. So this interface will look only into the routing instance which is applied to it. This routing instance is having, if destination is remote network, then it will look into the routing instance of this. Is it clear? If you have only one routing instance, all internal routes, external routes, you have to write in a single routing table. Even though this user is looking for internal network, he need to go through with all the 100 entries of your routing table, which one is matching. Is it reducing load or not? Now you understand what is routing instance. Is it clear? So like that, we will be creating multiple routing instances. First, when you create one virtual router routing instance, you will be adding interface which is related to that particular routing instance. See here, interface we added. Now we are writing a static route or dynamic route you can enable. Okay? See here, working with routing instance. Reference to corresponding IP unicast table for a given instance to view routing table content. So I am redirecting my routing instance to my default master routing instance, that is inet.0. See here, once you configure a routing instance and the device learns routing information within the instance, okay, automatically this Junos OS generates a routing table. If you use an IPv4 routing, that will automatically contact inet.0. If you are using routing table 6, that will automatically connect to inet.6. You need not to specify anything. When instance name is the name of routing instance within the configuration, means that is inet.0, new instance name, it is going to create a read write. It is going to rewrite the existing routing table. Means it is going to create a new routing table. Okay, this already we discussed. How to see this command? Show routing table and table name which shows entire your routing table. See here. Assume like that I have 10 routing instances. I want to test ping with one instance, not another instance. For example, 3 routing instances are there. Using one routing instance, I want to ping. By default, whatever you use ping or dig and all the stuff, that will take your management interface routing configured instance. For example, I have 3 interfaces. This one is connected to management network. Okay. This one is connected to LAN. This one is connected to WAN. I created 3 different routing instances. Management, LAN, WAN. Okay. By default, if you didn't specify any instance, you say ping so-and-so IP address. that will take only through management instance. If you didn't specify anything, that will take by default management interface routing instance. If you want to ping it, ping 10.0.0.1 by using a routing instance of my local area network. So at the time you need to specify, routing instance and your instance name. Using that routing instance, it will verify. Means using that routing table, it will identify the next hop. Clear? Now static routes. How to write static route we know. Yesterday we have seen set static route and you are going to specify your destination. If any destination 0.0.0/0, what's your next hop? You will be writing your next hop IP address. We know what is static route. How to configure a static route? See here. Edit routing -options. Set static route 0.0.0.0/0. Next hop you will give. Okay. For static, do you need to advertise? For static, do you need to advertise? By default, no advertise will be there. By default, no advertise will be there. Monitoring static route. Show route protocol static will give you only your static routes. Okay. Next hop resolution. See here. Resolving indirect next hop. By default, the software can resolve only directly connected next hop. Use the resolve option to allow resolution of indirectly connected next hop. What it means? My next hop IP address is so and so. If it is directly connected, for example, my internet ISP given me dragged a cable, given me IP address and a default gateway. So in my static route, what I will specify? My next hop is my default gateway. Okay. I have an I don't know after that what next hop is, but you can add a resolve command which will identify even the next hop of your ISP router to the next connected interface. See here. Now understand, this is router A. One interface is having this IP address. Two interface is directly connected to your router. But 5, if you observe 172.25.1.5 IP address is configured to the next hop. So if my router want to reach from 175.25.1 network to 175.20.2 network or 3 network, I know my next hop is .6. My next hop is .6, but I want to know even the next hop. If you give an option called resolve, it will automatically do a resolve, similar like your trace route. What trace route is doing? What is next hop? Then what is next hop? It is identifying, right? This resolve is going to perform the same task to identify even the connected next hops, indirectly connected next hops. Okay? Qualified next hop. If you say qualified next hop, the qualified next hop option allows you to independent preference for static routes of the same destination. Okay? So if you say qualified next hop, it says you have two different options to reach to the next hop. See here, if you look at show option below, from 172.29.100 network, if I need to reach internet, I am having two destination IP addresses. If you observe this diagram, now my traffic need to go to internet. I have two connections. Using ZA0/0/0, my next hop IP address is this 172.30.25.1. Using GE1/0/0, my next hop is .5. Now, primary next hop, due to default route preference, because this is statically connected, default route preference is 5. Okay, my next hop is this. But what qualified next hop is preferred? We will write qualified next hop. Means prioritizing. We are giving a prioritize saying that my qualified next hop is this. So what happens? First priority will be given to qualified next hop. Once again, you will change preference based on that preference. Secondary next hop due to the configure route preference. Route preference, if you give less than this 5, then default it will be taken as the next hop. Qualified next hop we will be writing to give more priority to a route. Now two routes I have. I want to give priority for one route. So we will be specifying qualified next hop. Dynamic routing. What is dynamic routing? We know method of dynamically learning routing information. Dynamic routing has following benefits. Lower administrative overhead, because if I am sitting at an enterprise network, is it possible for us to write each and every route statically? At bigger networks, it is very difficult to write each and every route statically. Increase network availability. What is increased network availability? Automatically, one network can able to get information of all the other networks. Availability of reaching other networks is easy. Scalability, even though it is, you are expanding your company, nothing you need to configure. Assume like that I have 100 branches, 101 branch I am starting up. In 101 branch router, I need not to statically write all 100 branch routing entries. If I configure dynamic routing protocol, it will advertise its routes and it will fetch routes from other routers which are advertising routing. Okay? This we know. Benefits of dynamic routing. What is benefits of dynamic routing? Dynamic routing resolves many of the limitations and drawbacks of static routing. Some of the most dynamic are lower administrative overhead, already we discussed. Increased network availability, already this also we discussed. Network scalability, growth of your network, that also we discussed. Now different routing protocols. See, different routing protocols, a summary of dynamic routing protocols. IGPs operates within single autonomous system, single network administration that provides for unique routing policy and flexible use of network resources such as OSPF, RIP, all this. EGPs operates among different autonomous systems, independent administrative entities that communicate between independent network infrastructures. Current EGP is used today is BGP, Border Gateway Protocol. So external you want or internal you want? Internal most probably preferred is RIP and OSPF, internal gateway protocols. External gateway protocols recommended is BGP, nowadays MPLS. These are external gateway protocols. Between network to network, we'll use external. Within the networks, we'll use internal. Theory. A link state of IGP, internal gateway protocol, reliably floods link state information to neighbors. It is going to automatically send continuously. Creates a complete database of networks. Create a complete database of network. Calculates best path to each destination. If it is OSPF, it will use areas. If it is RIP, within less number of hop counts. We know behavior of protocols, right? How OSPF will look? OSPF will look based on area IDs. What RIP will do? RIP will be do based on next hop count, number of hops it has to reach to the destination. So they develop their own set of information. This already we discussed. Case study. Use a single OSPF area to provide connectivity among all connected subnets and loopback address. Ensure that no adjacencies are formed on interfaces connecting to 172.20.x.0/24. Now all this we want to connect using a single OSPF network. Now what we need to do? We'll create one area ID. How many interfaces are involved in this? Check out GE0/0/1, GE0/0/2, GE0/0/3. I will add all these three interfaces into the same area ID. So what happens? Hello, हाँ बताओ. 2 minutes दे दो मैं बाहर आ रहा हूँ. 2 minutes. So to make it clearly to advertise these routes, what we are going to do? What we are going to do? Just create one single area, add these three interfaces into that area, enable OSPF. So what happens? Automatically they will exchange their routes each other and they can able to communicate each other, right? 192.168.172.20.1 network 3 dot network and 2 dot network. I want to make all three to intercommunicate each other instead of writing static routes. So what you have done, you created a single area, you added all the three interfaces into that particular area and you enable routing protocol. So automatically three routers will advertise, exchange routing information among each other, right? So see here, set area 0 interface 1, 2, 3. All interfaces are added. Okay. So just enable routing protocol. Now what happens? Show OSPF neighbor. In one router, if you see, next to two will be shown. If you look into router 1, it shows router 2 and router 3. If you look into router 2, 1 and 3. 3, 2 and 1. See, show OSPF neighbor. Will show your neighbor routers who are exchanging OSPF routes to you. Okay. Same what we discussed. In 1, it will show 2 and 3. In 2, it will show 1 and 3. 3, it will show 1 and 2 who are exchanging routes. Address of the neighbor, interface through which interface the neighbor is connected, state is down or up or how, router ID, it is going to give priority. Okay, default priority value is 128. Remember, this is also interview question. Dead, if it is dead, it will give you state as dead. Look into this OSPF routes, how to see show route protocol OSPF. Here we complete our routing. Then we'll see our next module, not next module, in this module only subtopic called routing policies. How to write policy based routes. How to write policy based routes means routing policy defines I want to import route. I don't want to export my routing information to neighbor routers. You can even do that. I just want to import routing information from neighbor routers, but I don't want to export my routing information to neighbor routers. That we will see in our next module. Take a 10 minutes break. We will see routing policies. Till now what we discussed is how to configure routing. Okay? Take a 5 minutes break. And this lab we are going to do now. We are going to create static routes, we are going to create a RIP, we are going to see OSPF.
సార్ చెప్పండి పాన్ కార్డ్ పంపించమన్నారా ఏది ఫార్మ్దా? ఓకే ఓకే, మెయిల్ చేసేస్తాను. ఓకే ఓకే ఓకే, ఇప్పుడు మెయిల్ చేస్తాను. మీ ఐడి ఫోన్. ఓకే ఓకే ఓకే.
सिम కొట్టుకుంటూ గూగుల్ అకౌంట్స్ లో ఇవ్వదు కదా. అది గూగుల్ అకౌంట్ ఫోటోలు
దేనికి సిస్టమ్ మీద కూర్చున్నావా? నీ పేరు ఉంటే ఆదిత్య. సిస్టమ్
అదే అదే అదే.
అందుకు అడుగుతున్నా, ఈ సిస్టమ్ యూజ్ చేస్తా.
ఆవిడే కాదు, ఆడే ఫారం పంపించమంటుంటే ఫారంది ఫారం చెప్పాడా? నాకు పంపించావా అందులో? హలో ఐఎం ఇన్స్టాల్ చేస్తే ఐఎంలో పంపించారా? వాట్సాప్లో లేదా? కాంటాక్ట్స్లోకి వెళ్ళి పైన రిఫ్రెష్ బటన్ ఉంటుంది, అది వరకు నాకు పంపిస్తే నేను పంపించేస్తాను. ఏది? అదే అయిపోయింది. ఇంటర్నల్ కూడా ఇది ఆడిస్ కదా నేను చేశాను మ్యాజిక్ అంటే ఆడిస్లో డేటా కాపీ అవుతుంటాను అది అతను తీసుకుని చెప్పించారు కదా అవ్వకపోనండి ఇంటర్నల్ అవ్వట్లేదు ఆన్లో లేదు కదా అయితే చెప్పి ఈఎమ్స్లోకి వెళ్ళి డెస్క్టాప్ డౌన్లోడ్స్ మన కాదు ఇది ఇదిగా ఇది వచ్చేది హలో ఓకే ఓకే ఇవాళ అయిపోద్దా మీకు ఓకే ఓకే
అంటే కొంచెం ఎంగేజ్ అయిన తర్వాత నాకు కార్డు కనిపిస్తే ఇక్కడ అయిపోయింది. అది ఇక్కడ ఉన్న బ్యాగ్లో ఉండిపోతుంది. ఇక్కడ తీసుకొచ్చాను వచ్చాను అసలు ఆడాలి
ఒకటి క్లారిటీగా ఏం కావాలో దానికి అడిగేసింది నాకు సార్ చెప్పండి నేను ల్యాబ్ చేయలేదు ఇప్పుడు చేస్తావా క్లాస్ వింటావా రేపు వచ్చి చేసుకుంటావా మళ్ళీ ఎప్పుడు వచ్చి చేసుకుంటావు ఇప్పుడు రావాలంటే లేదనుకుంటే నెక్స్ట్ డేస్ చేసుకోవచ్చు లేదంటే ఇంట్లో ల్యాప్టాప్లో చేసుకుని చేసుకోవచ్చు ఆప్షన్స్ నువ్వు చెప్పాను రెండు రోజులకి చాలు కదా రోడ్ ఎందుకు యూజ్ చేస్తాను ఇది అది చెప్పు చెప్పు నెట్వర్క్ ముందు ప్యాకెట్ ఫార్వర్డింగ్ యూజ్ చేస్తాం రెండు రోజులు ఎందుకు తీసుకుంటున్నావు నువ్వు OSPF కాన్ఫిగర్ చేస్తే ఆ రెండు ఎలా కమ్యూనికేట్ అయితే ఆ రెండింటి మధ్య నెబర్ రిలేషన్షిప్ ఎలా ఫామ్ అవుతుంది ఆ రెండింటి మధ్య డైనమిక్ రూటింగ్ ఏంటి అనే దానికి ప్రాక్టీస్ చేస్తున్నా రెండు రోజులు యూజ్ చేస్తున్నావు రెండు రోజులు యూజ్ చేసినప్పుడు ఏం చేయాలి రెండు రోజులు ఎలా కాన్ఫిగర్ చేస్తావు రెండు డిఫరెంట్ నెట్వర్క్ కాదు కదా రెండు డిఫరెంట్ నెట్వర్క్ కమ్యూనికేట్ చేయడానికి రౌటర్లో ఒక నెట్వర్క్ తీసుకుంటాము రెండు డిఫరెంట్ నెట్వర్క్ తీసుకున్నాం కానీ రెండు డిఫరెంట్ నెట్వర్క్ ఎట్లా తీసుకుంటాం అంటే ఒక నెట్వర్క్ ఈ రౌటర్లో తీసుకుంటాం ఇంకొక నెట్వర్క్ ఆ రౌటర్లో తీసుకుంటాం తీసుకొని ఈ రౌటర్కి ఆ రౌటర్కి మధ్య కనెక్షన్ ఒకే నెట్వర్క్లో పెట్టుకోవాలి. అది క్లాస్ 30 తీసుకుంటావు. ఏదో నెంబర్ క్లాస్ 30 2 ఎండ్ కమ్యూనికేషన్ తీసుకుంటావు. తీసుకున్న తర్వాత ఈ రౌటర్ నుంచి ఆ రౌటర్లో ఒక ప్రోటోకాల్ కాన్ఫిగర్ చేస్తావు. ఈ రౌటర్లో ఒక ప్రోటోకాల్స్ అంటే ఇవే ఈ OSPF కాన్ఫిగర్ చేసి చెక్ చేస్తావు కమ్యూనికేట్ అవుతుందా లేదా. సో అందుకోసం డిఫరెంట్ ప్రోటోకాల్స్ కావాలి, డిఫరెంట్ రౌటర్స్ కావాలి, 2 రౌటర్స్ కావాలి, 2 నెట్వర్క్స్ కావాలి. ఇప్పుడు నీ కాడ ఏముంది 10.4, ఒక నెట్వర్క్ 20.4 తీసుకోవాలి. నా దగ్గర నుంచి ఆప్షన్స్ లేదు, సేవ్ చేసుకుంటాను చేసుకోవచ్చు. లేదు మీ ల్యాప్టాప్ మీ కాడ ఏమైనా సిస్టమ్ చేసుకొని చేసుకోవచ్చు. ల్యాప్టాప్ వస్తుంది 4 GB. ఎంతసేపు క్లాస్ స్టాప్ అయింది? ఓన్లీ రౌటింగ్ ఫస్ట్ స్లైడ్ అయినా ఫస్ట్ మాట్లాడలేదు.
అది పార్క్ చేసుకుంటారా? పేమెంట్కి వెళ్ళిపోతున్నావు. పేమెంట్కి వెళ్ళిపోతున్నావు. ఎన్ని రోజులు? సోమవారం తెల్లవారు క్లాస్ ఉంటా. సోమవారం తెల్లవారు
ఫైనల్ స్పెక్ట్రమ్ ఉంది, స్పెక్ట్రమ్ ట్రైనర్ దానికి దాని ఎక్స్పీరియన్స్ మనకి ఐపీసీ పీపీఆర్ అంటే ఎందుకు వెళ్తారు.